try to be as brief as possible. Yeah. So first, we'll be learning about the concept of unidimensional measurement using, we call income standards, or you can call it achievement standards, however we call it. But it's a single dimensional tool, how we look at sizes of a distribution. I will talk about it more, and inequality. And then in afternoon session, we'll go to the property measurement in single dimension. Sounds good? Okay, so let's start. For your reference, this is the book we'll be following. So this is the World Bank published book that I wrote with my co-author. It has some references, but if you need further references on any particular issues, please come and talk to me and ask me. I'll happy to share it with you. Yeah. Okay. Given that I'll be doing a lot of things from the keyboard itself, I will try to bring everything in the slide and then go through it. Yeah. So first, very quickly, let's talk about preliminaries, the notation that we'll be using throughout these module, at least for up until Thursday. Yeah. So we will be using, we'll be assuming, suppose there are n people in a society, even when you are doing measuring energy poverty and so on, you have to understand, you'll be using sample service. We'll talk about sample service, how to do everything, data analysis later. But for the theory part, technical part, let's just assume there are n people. Yeah, denoting by capital N. And we will be assumed that their achievements, it could be income, it could be consumption expenditure, you may have particular type of energy indicator in mind, but we'll be assuming that they are cardinal for now to start with. What do you mean by cardinal? That means numbers make sense. If you are saying 100 pound or 10,000 rupees, you have this number in mind and then makes sense, right? If you move from 500 rupees to 1,000 rupees, you can say that my income has doubled and so on. We'll be talking about other kind of indicators. They're called ordinal indicators, where the order makes sense, but the cardinal value itself do not make sense. If you are saying, are you happy or not happy? Can you assign any number to it? I don't think so. So I will be focusing on today for the entire day on cardinal numbers. That means where the number makes sense. You can do multiplication, you can do subtraction, addition, and all these things. And for simplicity, can you see when I have the writing at the bottom of the slides? Yeah, maybe why don't you reorganize from this side to that side? Yeah, I should have asked that before we start. Is it okay with you to see? Oh, you can see from here as well. Oh, okay, you have other ones. Okay. That's fine. Yeah. Just let me know if you have any trouble, seeing anything. Yeah. So for simplicity, I'll just assume that, all these values, they are kind of ordered in that sense. X1 is the lowest value and Xn is the highest value. Lowest income, highest income, and so on. And we can summarize all these values using a vector. Okay. Now, a vector is fine. When you have four numbers, you just write them as 1, 2, 3, 4, 3, 4, 5, 7. When you have 1 million numbers, how do you summarize? When we have 1 million income, information of income, we cannot use just this number. We used to have graphical tools, or we can use a distribution. Okay. So for graphical representation, we can use tools such as quantile functions, distribution functions like probability distribution functions, probability density functions. How many of you have heard about distribution functions, density functions? How many of you have not heard? Please raise your hand. There is nothing to be, be shy, so that I know. So you all know what, oh, you didn't. Okay, so I will explain slowly. And if you have any question, again, stop me and ask, yeah? Okay, so what is a quantile function? Suppose we have graph. You have seen graphs, all of you? You understand graphs, right? So suppose you have these diagram where you have income on the vertical axis and you have cumulative population share on the horizon. So population share has to be between 0 and 100%, right? And on the vertical axis, you have income, suppose. Yeah. Then suppose that is the highest possible income, xn. Now, if, and this is, of course, the 100% population share, this is how a quantile function looks like if you plot it. So if you have 1 million income observations, you have 10 million income observations, it doesn't matter. You can just summarize them with a quantile function. Yeah. And we will be denoting this quantile function by qx. Q stands for quantile. What does the point on a qx tell us? So that's the point, right? Because I'm using it, I'm summarizing, but what does a point on this quantile function mean? Suppose we have a point such as A. Yeah. And for the point, suppose the population share is 0.5. What it is asking, a quantile function gives us different percentiles. So what it is asking here, that you have what income you should have on the vertical axis below which the income of the 50% of the population lies. That's what it answers. So you would say BM is that income below which income of the 50% of the population lies. That is also the income above which the income of the rest of the 50% lies. That's what a quantile function is. So if you have, say, 90th percentile, this is called 50th percentile income. If you have 90th percentile income, that means it is that income below which the income of the 90% of the population lies. So in your different exams, when you take, say, joint entrance exams or anything, people say, okay, he has got 99th percentile income. He has got 90th percentile income. That's what they are. So you use it for marks, you use it for income or summarize anything. So quantile functions can be used to summarize. And if you want, what is the 95th percentile? Choose the population share over here as 0.95. Draw up vertically. That's the 95th percentile income. The 95th percentile income means it is that income below which 95% of the population's income lies. That's what it is. Clear? The curve of quantile function is it can take different shape. Straight line also. It will be straight line. That means these incomes are increasing in the same proportion. That means bottom 50% has this particular level of share of income. 25%. So it has to be linear. But in real life, when you plot, they're not linear, because it is possible that bottom 50% of the population, they have only 10% income share, right? So if you have something linear, that means share of everybody's income to total income exactly the same, which is not the case. Yeah, you will have this linear function. Yeah. But starting from zero, the curve is like increasing. As I said, it is not just, it is just one theoretical curve. It can be very much like all the way, and then you have only out there, or you have little bit only here, goes just like this. So it can have any shape, but it has to be increasing. This is the ideal curve, so we can study the quantiles of function. This is just one of the many ways of looking at it. But the curve in your actual application, it may take different shape, but it has to be increasing. It can be concave, convex, however it does, it doesn't matter, but it has to be increasing. It is. This is what, this is an empirical observation. Theory also, theoretically, it cannot be downward sloping. It is not possible. Then ranks will change. So you rank everybody from lowest to highest. Then you have the population share, and then you draw. This is going to, it is typically going to look like increase. But sir, after increasing returns, like at the starting of the curve, the rate of change is increasing. But at the point of 0.5, after that, the rate of increasing is. As I said, this is just, I just drew it. So I didn't draw it because it has to look like that. It can look different. It can be completely concave, or it can be completely convex. However it is. This is just one. I just drew it just to show you. So I did not draw it with the mind that exactly where the inflection is going to be. No, this is just a particular way of looking at it. As I said, it is very much, if you completely concave, you don't have to take this shape. So it is not necessary. This is just one example. As long as it is increasing, it's fine. But this is how they typically look like. Have you ever seen a probability distribution function? I will show it to you. It is just an inverse of a probability distribution function. I will come to that. Let me show you. Yeah? Any other questions? Clarifying question? Okay. So, what is BM here? BM, the income, is called the median income. That means it is the income at the middle, below which the income of the 50% of the population lies, above which the income of the 50% of the population lies. Now, can we obtain the average mean of the distribution? It turns out mean of the distribution is just the entire area at the bottom of the quantile function. This is the average of the distribution. So if you ask, distribution of what is the average? It turns out the average is the entire area, the gray shaded region under the curve. Just for your information. Yep. Okay. Now, what is a cumulative distribution function? Many of you may have heard a CDF, right? Or a PDF. Many of us who have taken statistics, we have heard about this, right? What is a CDF? And how is it related to quantile function? So cumulative distribution function is simply an inverse of the quantile function. Yeah, I'll show you in terms of the diagram. So this is our quantile function. Yeah, we are just going to flip the axis. So we have our income. We plot it instead of vertical axis. We plot it in the horizontal axis. We take the horizontal axis of population share. We plot it as vertical axis. And then the maximum, of course, comes there, xn. And then this maximum value of 1 comes there. And there you go. You plot the curve. That's your cumulative distribution function. Now, does it always look like exactly like this? Not necessarily. It can take different shapes. It can be completely convex like this, but it has to be increasing. A probability distribution function cannot have a segment which is going down. This is what it is. Now, empirically, they look different from situation to situation. They don't have to take this exact same shape. Yeah, we will see when we are doing, whenever we are doing state exercise, we'll try to plot some of this curve and you'll see how it looks like. Sounds good? Okay. So quantile function is just the inverse of the CDF. Now, we'll be using these two tools interchangeably. For example, for inequality and say size analysis, size of the distribution, we'll be using quantile function. You will see it's much easier to understand. When we do poverty analysis, we'll be using the cumulative distribution function because it has direct meaning and direct link to poverty analysis. Okay. So now, just a little bit of more information about cumulative distribution function. So what it says that given a particular level of achievement or given a particular level of income, the CDF for a distribution X is going to be denoted by Fx. So the cumulative function was Qx, distribution function is Fx. So if P is say 1,000 pounds, you could use 10,000 rupees, however you do, a particular value. So if P is a 1,000 pound, then the cumulative distribution function for that particular value is the proportion of people in the society whose income are below this 1,000 pounds. That's what it is. This is what cumulative distribution is. So you set a 1,000. So suppose what is the, who can tell me the poverty line in India at this moment? What is the poverty line in India at this moment? 1,500 and 1. Is it in terms of consumption expenditure or in terms of calories you're saying? Calories only for consumption expenditure is the measurement of unity. Agreed, but what is the income or consumption expenditure below which somebody is identified as poor? 26 for rural area, 32 to 33 for urban area. 33 per day, suppose. Okay, 33 per day per person. So if instead of this, if B is 33 rupees per day, then that will give us, the CDF will give us the proportion of people whose income is below 33 rupees per day. That will be our headcount ratio. Yeah, we'll come to that. So that's the direct link with the distribution function. It will be more clear after lunch, in the post-lunch session. Yeah, we'll come to that. Okay. So have you heard about $1 a day, $2 a day? Yeah. So FX $1 a day is directly going to give you the proportion of people whose income is below $1 a day. If you have FX $2.15 a day, which is the current threshold set by the World Bank, you will have the proportion of people whose income is below $2.515 a day. Okay, so your distribution function directly gives you the proportion of poor people, and that's the direct link. We'll come to that. Okay. Now let's talk about a bit on what we mean by achievement standards. So you have a distribution of achievements, which could be income, which could be consumption, expenditure, and you may want to understand what is the implication. How do I summarize? I have this 1 million income. What to do with this? Can I say if we have 1 million data point in this period, 1 million data point in another period, can I say that income has gone up? Can I say the situation of the society has improved, gone down, and so on? So a quantile function or CDF, as we said, that gives us information of the entire achievement distribution. How do we represent the size of the achievement of the distribution? We may require some statistics. And you know what is the most common statistics people use? You all hear about growth, right? Economic growth. What is growth? Change in GDP per capita is very important. Now, when you say GDP per capita, is an average. So when we talk about growth in general, we talk about the growth of the average. So average is one measure, one statistic to summarize the entire distribution. And that is most frequently used because that's the easiest to understand. But that's not the only one. Let's try to have a look what other options we have. Yeah. So we are going to just refer to the statistics as achievement standard. If you look at the book, we refer it as income standard because we take the income variable to analyze everything, but they literally mean the same. Yeah. So there are different kind of standards, mean, median. You have all heard about it, right? Mean is the average, you just said. Per capita GDP, this is mean. You could have median, you could have different income percentile, and there are other measures as well. And they have implications on poverty measurement too. We'll come back to that. Okay. So we are just going to denote the achievement standard of a distribution by this notation, which is W. W will denote well-being, welfare, achievement, however you call it. We will be using the notation W to denote an achievement standard. Yep. Now, what I want to go through now, in 10 minutes, that it is very important that we understand the principles or properties of these standards. We should have some underlying value judgment that we want these standards to satisfy. Okay, let's consider some examples. I will come to that, and then we will progress accordingly. Now, what are these properties? It is very crucial to understand how these income standards or achievement standards, however you call it, how they vary because of different data transformation. Yeah. And I will tell you that I'll show you that how important they could be for policies as well as theoretical point of view. So I'm going to ask you some questions. I will give you some, two vectors next to each other, and I will ask you whether you evaluate one distribution better than the other. Yeah. Please bear with me and please answer. Please do not stay silent. Yeah. First one, I give you these two vectors. One is x, 1 to 3, 4, X prime 4, 1, 2, 3. Yeah, so if think of 4-person society. In one society, the income is 1 for 4 people, income is 1, 2, 3, 4. In another society, the income of these people is 4 to 4, 1, 2, 3. Do you have any preference? Which society is better? Which society is worse? They're different, they're same. You will rank them same. Okay. What about this society? One society has income 1, 2, 3, 4. There are 4 people. Another society has 8 people. They have this income 1, 1, 2, 2, 3, 3, 4, 4. Are they different? Are they the same? Same. You all agree? Anyone disagrees? Anyone would say they are different? No? You all agree? Okay. What about these two? You have X as 1, 2, 3, 4, and then you have X prime as 1, 4, 3, 7. Which society is better? Which society is worse? X prime is better. X prime is better. Why? One by one. Start with that.
Some individuals explain having income which is at least equal or better than X.
Okay.
The average income of
why are you taking average? Average is a measure. How do you know you have to take average?
So it depends on what you are trying to understand from this. If we are trying to understand the average of the society as
No. Why do we always think about average? That is the main point.
Yeah, that is what I'm
No,
saying.
you cannot.
I think first one is better because in the second case there are no variance. It looks like the variance is higher in the second case.
Now you are going to variance. So look, you all are looking at different things. It's just like that elephant. You're closing your eyes and you are touching different parts and you are saying, oh, it's a column, oh, it's a stick, it's a round shaped thing. You see? Do not go to any statistics first. That's the philosophical justification. Do not go to median. Because depending on what you want, you will choose the indicator or statistic. So the first answer was looking at, you have the distribution, you ordered them. So the first one is order 1, 2, 3, 4. Let's order the second one, 1, 3, 4, 7. Now if you compare person by person, you will see in the second vector, you have at least as high as income, right? Income is higher. So whether you use average, whether you use median or anything, you should say second society is performing, X prime is performing better than X. Not just average. Average is one indicator, and we will talk about it whether to use even average. Average has a lot of problems. It masks a lot of problems.
Isn't it the case that the first society is more equal than the other?
I am not talking about equal, I'm just talking about size now. I'm not talking about disparity. I'm just talking about size. In terms of size, the second society is bigger than the first society. We have not come to the theory. We are just looking about examples, right? What about this one? One is 1, 2, 3, 4. The other one is 1, 1, 3, 5. Which society is better? Now, when I'm saying which society is better, please do not think that everybody has to think in the same way.
Both are equal.
So some are saying both are equal. Why?
In two different ways, one better than the other, and in the other one, the fourth rank is better than the.
And why are you saying these two societies are the same? They're equal. Think of situations where you and your friends, they have same income of 500 rupees. Think of a situation, you have 300, she has, or you have 400, she has 600. Are they the same? No, right? Okay. Who else would like to go? But I'm not saying you're wrong. It's your value judgment to say they're the same. Yeah.
In total, the society is consuming or has the same income.
Same. Also.
So because although the first set, the X set, and having the size of the first set and the second set is almost equal. although the distribution varies.
So you have the same size, but different distribution. So if you look at the total income, they're exactly the same. Okay. So this is why we go for lexicographic ordering, like dictionary, right? What happens? We look at dictionary, all the A's they have to first, but if they are equal, we go for the next letter. If they are same, we go for the next letter, right? So here it's good that we have the same size. Then how do we compare two societies with the same size? We look at their distribution. Do you think both societies are equally unequal? Which society has more inequality?
X prime.
X has more inequality?
X prime.
More equality, X prime has more inequality. So when we have same size, we go for the next ordering inequality. That's where variation comes into place, right? And what about the last one? I have 1, 2, 3, 4, and then I have 2, 4, 6, 8. So definitely one society X prime is better, right? How much? You said double. How? So you see, we are reflecting a lot of value judgment, and this is very crucial for measurement. We cannot just select randomly a particular measure and say this is our measure. Average or mean is a random measure. You have to have a justification. Why are you choosing average? Let's try to look at those. Why we choose these particular measures. Okay. Let me talk about the different properties. The first one is called symmetry. Symmetry is the last example. First of the examples in the previous slide. You had 1, 2, 3, 4. You have 3, 1, 2, 4, or whatever. And you all said they're same. Technically, what is called that if a distribution is just obtained by just permuting the income, okay, you have these people, we all suppose have some income, and I said, okay, I'm giving my income to you, I'm taking your income, If you just swap this income, it does not change the overall situation. That is called anonymity. That means is the income distribution that matters, does not matter who has what. Yeah. Second, called population invariance. So you take one country, or suppose you take one state, you take Uttarakhand, and you create Uttar Pradesh. It has a different population size. But suppose hypothetically, you take Uttarakhand and you just clone these people. I'm from Uttarakhand, suppose I have been cloned 10 times. You are cloned 10 times, and so on. You create another population. So it is just replication of my income 10 times, your income 10 times. Does it make a difference? Well, they said no. Why should it be different? China is a bigger country. Fine, India is a big country, and probably United Kingdom is a small country. GDP wise, China actual total GDP, China is really big. India is really big. Their GDP is larger than the UK's. Would you say standard of living is exactly the same in these two countries? Okay, so this allows you comparability. If you just take one income distribution and replicate it, it does not mean your well-being increases. Yeah. Third one is called monotonicity. And this goes back to the example where you had one distribution having at least as high as income when you order them. So that means as if we have a society today, everything else, all else equal, suppose one person's income increases. That should be considered as the betterment of the society. Okay, that's called monotonicity. Should I use average to understand? Not necessarily. Yeah. Transfer principle says if one distribution is obtained from another distribution by regressive transfer, so you have the total size of these two distributions same, but you take money from the poor and give to the rich. It says, it should affect your size or your income standard, achievement standard negatively. Take the average. You have 1, 2, 3, 4. Yeah. You take some money from the first person or for the second person who had 2 and give it to the richest person. So your distribution becomes 1, 1, 3, 5. Did the average change? Average is exactly the same. But is it something better? Is it something that you said, oh, taking the money from the poor and giving to the rich is a good thing to do? But your average didn't change. The average will say the same level of well-being, but actually these two distributions are different. Should we have used average? You have to be careful. So when you do per capita GDP growth, it has no bearing understanding inequality. Even in a society, inequality is increasing. Growth will just say, oh, the size has gone up, growth has happened. Oh, inequality has also gone up. Growth doesn't look at that. That's the problem of looking at average. So you have to be very careful not to jump the average at first. Yeah? Now, what is regressive transfer? Just graphically, suppose you have this income distribution 4-6. You take this 3 unit from the poorer person and you simply give the unit. So your distribution moves from 4-6 to 1-9. Which one is the preferable distribution, 4-6 or 1-9? 4-6. This is called a regressive transfer. Now we have our tax system, right? How does the tax system work? Do richer people pay more tax or poorer people pay more tax? Richer people pay more tax, right? This is called a progressive tax system. This is exactly the idea. You are taking more people, more income from the rich as tax, you are giving it to the poor. So that will be a progressive transfer. It's just the opposite of this one. So if you start with 1-9 and you take some money as tax 3 and give it to the poor person, that's called a progressive transfer. So going from a good distribution to a more unequal distribution is called a regressive transfer. But starting from a more unequal distribution, if you come to less unequal distribution, a more equal distribution, that's called a progressive transfer. Yeah, progressive transfer with the same average should increase welfare, should increase, it should be better for society. Do you agree? Okay. Now I ask you a question. Okay, I gave you 1, 2, 3, 4, and I gave you 2, 4, 6, 8, and I asked you, oh, how much should welfare increase? And you just said double, right? This is what is called linear homogeneity. If you are happy with that okay, everybody's income in the society has doubled, why shouldn't the overall measure should be double as well? Suppose everybody's income increases by twice, and suddenly welfare increases by 3 times. It's unintuitive, right? It doesn't make much sense. So linear homogeneity says that if everybody's income increases by the same factor, your well-being increases by the same factor as well. It's just a convenient property that people use. And finally, if everybody has same achievements, everybody has same income, then that becomes your standard. If everybody, suppose all of us in this lecture theater has an income of 10,000 rupees, then the index itself becomes 10,000 rupees. It doesn't make sense to call it 9,725. Why? If everybody has same income, that becomes our standard. Okay. Now, this property is quite important. This is called subgroup consistency. So suppose we divide India into north and south. Okay, suppose we have this particular way of classifying. We take 15 states, we club them as some way. We take the rest of the 15 states, 14, 15 states, club them in particular way. So we have mutually exclusive and collectively exhaustive two groups, right? Now, it's a question for you. Suppose you have no change in the income distribution in the north. Northern state, there is no change. In the south, the income standard improves. What should happen overall? No change in north, change into improvement in south. Overall, you would expect it to improve, right? There are measures that can lead to a decrease. You have to be very careful. So subgroup consistency requires if you divide them into subgroups by say gender, males and females. If the male's income did not change, female's income increased. The overall, it should increase. That's a form of consistency, and that's called a subgroup consistency. Okay? And you will see eventually that there are many measures that do not satisfy some of these basic principles, but we use them. Okay. So if you generally, if you divide, the population subgroup, it could be gender, X prime could be gender, it could be male, female, or as I said, North India, South India, so that the total population, of course, is the sum total of the subgroup population. Then you obtain distribution Y with the same population size, suppose didn't change, subgroup consistency required that given the population size, if your standard for one subgroup has increased, for the other subgroup it can either increase or remain same, then as you said, overall there should be an increment. That's what it is. Yep. Okay. Now, what are these income standards? And probably you have heard about some of them. Yeah, please let me know if you have heard about. Quantile percentile incomes. Have you heard about them? 25 percentile income, median income, and so on. Partial means you have heard about that, but probably didn't realize. What is the average income of the bottom 10%? What is the average income of the top? What is the average income of the top 10%, and so on? You may have heard, may have not directly used, but you have used them, right? Heard about that. General means you may not have. Some of you may have, some of you have not. Yeah. Our average is one particular type of mean here. Then something called sane mean. We named it after Amartya Sen, Amartya Sen. It is called sane mean. We'll explain you. It's just different way of averaging. Okay, average, what we take for per capita GDP is just one of these many potential, choices. Okay, so these first two income standards, they depend on the part of the distribution, but the last two, they actually depend on the entire distribution. Entire distribution means entire quantile function, entire cumulative distribution. Okay, how do we do this? Okay, so first of all is the quantile achievement. It provides the information about different parts of the distribution, and people find it quite useful. They can be directly computed from the quantile function. So let's denote this pH quantile by this particular notation. So we say W because it's income, it's an achievement standard, and quantile income. Yeah. So for a particular percentile, this is our quantile income in terms of graph, how it looks like. So you have this percentile quantile function. For 10th percentile, you have QX, 25th percentile, this is your median, this is your 75th percentile, and this is your 90th percentile, and so on. If you go to Stata, some of you use Stata, right? If you just use if you type sum, sum of the variable, it gives you the mean standard deviation, right? Try sum of the variable, comma, D for details. It gives you 50th percentile, 25th percentile, and so on. Hopefully, Pratap is going to show some of those, right? You can get those the percentages that you get from there. If you think clearly, they are just different part of the quantile function. That's it. Make sense? Can you link? Yeah. Oh, yeah.
Can you just explain the second point for this achievement of given percentile and the previous slide?
Yeah. Which one?
The second one. We denote the quantile achievement for the peak percentile of distribution.
Yeah. So quantile. So the income standard here, the quantile, the point on the quantile function themselves. So there you go. Q10. That means this is your income standard, right? Your income standard is the quantile itself. That's what it is. You will see, I will talk a little bit, just for half an hour. You talk about 90-10 ratio. What is 90-10 ratio? 90-10 ratio, you take this value divided by this value. That's your 90-10 ratio. But everything you actually can see from this graph. Conceptually. We use those concepts, but where do they come from? There you go. Once you have that entire thing, you can compute whatever you want.
And we can conclude here that if one person or individual or society has a higher income percentile, their achievement is also high.
Your achievement is the quantile itself. Okay. So suppose you are saying, okay, is US richer than India. You look at the median income in the US, you look at the median income in India, and then you compare, people in the middle person in US is 10 times richer than in India. It gives you the comparison, right? So instead of taking the entire distribution or average, you just take the median. So there you go. Your median would be an achievement standard itself. Yeah. Or it could be other parts. Yeah. Okay. So this is, people use quite a lot these percentiles. And as I told you, for your achievements in your marks and grades, what is the achievement? 90th percentile, 92nd percentile, 93rd, and so on. That's what it is. Yeah. Now, what are partial means? Partial means provide information about mean of different percentiles. That means you are saying average of the top 10, average of the bottom 10. Now, how do you get in terms of the picture? Yeah. So we define something called lower partial mean. This is the mean or the average achievement below a specific cutoff in the percentile. Say mean income or average income, the bottom 10%. An upper partial mean is the mean of the achievement above a specific percentile cutoff. Yeah. In terms of graph, what do you get? You have this quantile function. Suppose you have this bottom percentile, which is P prime, so bottom 10%, and there P double prime, suppose you have 98%. So it is the top, it will give you top 10%, right? So suppose you have these percentiles. This is the percentile corresponding to P prime. This is the percentile corresponding to P double prime. And there you go, you have these two areas. These areas give you, so instead of looking at the entire area, you are looking at the areas of these two. So these are all the incomes over there of the bottom P prime. So if it is 10, then you have bottom 10% of the population. Okay? And this is all the income of the bottom, top 10% of the population, suppose. Yeah? Then it turns out the average here is graphically is the area divided by this, because you are looking at the average of everybody over here. Similarly, if you compute here, this gives you the average of all incomes, which is the area divided by 100 minus P prime. So that is the top 10. This is 90th percentile. You have 100 minus 90, 10. That gives you the average. So these are partial means. So instead of just looking at the percentiles, you are looking at, okay, what is the income, average income of everybody in the bottom 10 or top 10? And what people do, people also take ratios. And people just say, you have heard about Kuznets ratio, Palma ratio. Have you heard about those? They use this technique. So for Palma ratio, I think the ratio was 40%, 10%. So they divide the distributions into 40%, poorest 40%, middle 50%, and the richest 10%. And then they look at the share of the top 10% average, and then the bottom 40%. That's the inequality measure. That's how they get it from the distribution. Yeah. So all these measures you will hear about, people come up with these different indicators of inequality. It is just a game that they play around this quantile function. Yeah. Okay. So now let's talk about general mean. This one I would expect you to pay some attention, because this is, it may not look new to everybody, all of you. Some of you may have heard this concept, but let me go through. Yeah. Okay. So it is a class, an entire class of normative standards, and this is how they're expressed. Looks clumsy. Any of you, have you ever seen this particular functional form? Does it look familiar? Yes, no? Okay. So it's the value of this alpha, the parameter ranges between minus infinity and plus infinity. What if alpha equal to 1? What is it for alpha equal to 1? Any of you? It's the average. It's the arithmetic mean.
Yeah.
What about alpha equal to 0? So for this one, use this functional formulation for alpha equal to 0. What is this? Have any of you seen it? It's geometric mean. What about alpha equal to -1? Harmonic mean. So you see, it's different kind of mean, but they have used in inequality measurement or income standard measurement. Okay. It turns out if you have an alpha value, okay, so this one, if this is lower, then the value of the income standard becomes lower. Okay, so I give you a distribution. You compute the arithmetic mean and the geometric mean. Which one will be higher, arithmetic mean or geometric mean? Arithmetic mean. Between harmonic mean and geometric mean, which one is higher? So you see, you are reducing the value of alpha. The value itself goes down, right? Even for the same distribution. The idea is that lower value of alpha put more weight on the lower incomes. So in a way, you are emphasizing more on inequality. So if you are inequality averse, if you do not want inequality, you would probably rather use geometric mean or harmonic mean, not the average. So this general mean is one way of assigning or putting more weight on the lower end of the distribution. If there is inequality, then always geometric mean will be lower than arithmetic mean. But if you have a distribution where everybody has same income, your arithmetic mean, geometric mean, harmonic mean, they all will be the same. But if it is an unequal distribution, you will always have geometric mean lower than arithmetic mean, harmonic mean lower than, and so on. Yeah, let's try to have a look at it graphically. Now, if all elements are equal, then well, all general mean they are just equal. Yeah. So for alpha equal to 1, as you said, arithmetic mean. Alpha equal to 0, geometric mean. So you have already heard about it. Actually, you knew about it. It's not new to you. Yeah. Alpha equal to 2, Euclidean mean. Now, when alpha equal to infinity, you put all the weight on the maximum income. So that's your maximum value. And when alpha equal to minus infinity, you only care about the minimum value. So that takes you something called a Rawlsian world. Rawls was a philosopher who said, you know what, you should care, you should be maximum inequality averse. What does it mean? That you should only care about the income, improvement income of the poorest person of the society. Okay? You are the most inequality averse in that case. That you are saying, you know what, I don't care what happens to other people. If the person who is the poorest, if that person's situation did not improve, I do not consider it an improvement. Definitely, Rawls will not go for the average because average completely ignores inequality. Does it make sense? Yeah? Okay. So lower alpha puts more weight on lower achievement. So you have all used arithmetic mean, geometric mean, harmonic mean, Euclidean mean. You have used them for different purposes, but that's how they can be used to capture inequality in a distribution. Sounds fun? Okay. Okay. So suppose we have a distribution where all elements are not equal. So suppose there is inequality in the distribution. So you plot these values, against this parameter alpha. Alpha equal to 1, that's your average, arithmetic mean, WA. Then this is your geometric mean. Look, the value should go down. Yeah? -1, harmonic mean. Alpha 2, Euclidean mean. Can you tell me where you use this Euclidean mean? Have you used this x squared somewhere? What do you use when you use variance? The variance formula of variance, right? 1 over n sum over xi squared. You see, that's the Euclidean mean you use. That's what the application of Euclidean mean. Yeah. But here, if somebody uses Euclidean mean, then that person is inequality lover. That person would say more inequality is good for me. Okay. If you are not an inequality lover, you will choose something less than 1. Okay. And then that is the maximum value. So this is, if you join, this is how a general mean curve look like. But this tool can be used for inequality analysis and as well as, putting more weight on the lower end of the distribution for size. Sounds good? Any question here? Okay. The last one is same mean. It is also an average, but a different way of averaging. And spoiler alert, this is linked. Have you heard about Gini coefficient? Any of you? This one is linked to Gini coefficient. Okay, and I will show you how it is used. Okay, what is same mean? So this is, so if you look at our average mean, it is the expected value, right? It's the expectation of X literally. This is the average. What same mean does, it is the expected value or a single, that's achievement, not achievement, whatever. It's late night mistake typo. It is randomly drawn from a population. So what you do, you are picking a pair of income. You are drawing two incomes at the same time and you are retaining the minimum. Drawing two incomes at the same time, keeping the minimum. This is how it should be seen. So how it looks like, mean, I'll put the mean formula below as well. This is what average is, right? You have 1 over n, the population, and then you sum all the income. That's your average. Same mean is you have 1 over n squared. Why? You are taking every pair of income. So if you have 5 people, you are doing 5 times 525 because you are taking the pair every time, yeah? So the denominator becomes 1 over n squared, but then you take sum over all this minimum value. So you take them, so you put different weights. So if think of it, if you have 5 people and you are taking the pair 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. So your minimum value is repeated 5 times. Right? Similarly, you do for other one. So if you do that way, then you have total 25 observations. That's what n square is coming from. So this is the value of same mean. Now, how do we use it for, putting more weight on the poor? Let me show you the weights that poor get. So the highest person do not receive a weight of 1 over n, but receives the value of 1 over n squared. The second richest gets a weight of 3 over n squared, and so on, 5 over n squared, up until this is the second person, this is the weight it gets, and the poorest person get a weight of 2n minus 1 over n squared. Look, the weight is increasing, so you are putting more weight, so it's an unequally weighted average, where you are putting more weight on the poorer and less weight on the richer. So if you have inequality, that weighted average of same mean will be lower than the average, and that difference can be considered as loss due to inequality. Yeah, we'll come to that in a while. Okay, so the same mean actually can be expressed as an unequally weighted average, where you put the highest weight on the poor and the lowest weight on the richest. That's what same mean is. It's just a different way of averaging. The general mean does it in a different way. Same mean does it in a different way. Understood? Okay. Now, the question is, you talked about these different measures. How do they go with the properties? Are they well-behaved children? Satisfies everything? All the tasks? Okay. Let's look at quantile achievements. Okay? The one we got from the graphs, quantile means, percentile means, yeah? They're very good. If you swap everybody's income, the distribution doesn't change. It satisfies symmetry. Population invariance is satisfies because when you replicate, your quantile function or your distribution does not change. Fine. Does not satisfy monotonicity or transfer principle. Yeah. Suppose you have some people. So suppose you are looking at the bottom 10th percentile and top 90th percentile, right? And somebody's income in the middle has changed. Better for the society because somebody's income has improved. No change in the 10th percentile or 90th percentile. Doesn't satisfy monotonicity. Or you have a progressive transfer between, say, the 60th percentile and the 40th percentile. They don't capture. 10th percentile, 90th percentile would not capture. So they do not satisfy this. So, interested to understand how distribution has changed, you should not use these two methods. So if somebody comes and tells you, oh, Palma has changed, Kuznets has changed, 90-10 changed, You will ask, okay, what about the distribution? What about changes in other part of the distribution? Have you captured? If they said, no, we do not know, what's the use? So you have to be careful. So sometimes we blindly use different measures, but you ought to know what you are missing out. That's why it is very important to understand these tools. So you should be able to say, I have used this measure, but I know that I'm missing out on certain things. In academia, it is very important to know your strength, but also to acknowledge your weaknesses. Whichever academic paper you write, there is nothing called a complete paper. Even the paper written by a Nobel laureate can be attacked and challenged. Okay? When we do academic paper, it is not a Bible. Okay? It has to be challenged, every academic paper. So whatever tool you use, they have their limitations. There is nothing called a perfect measure. Knowing their strengths, they're good. You are saying, oh, this is the strength. But you need to understand their weaknesses too. That makes you a good academician. Whenever you are saying something, you also be, it is not about you are not going and selling product. That you always have to say, oh, this is it can do, this is it can do, is academia. I know you are trying to make a change in the society, but at the same time, you need to be acknowledged what is the problem with my measure. Every measure, trust me, there's nothing called a perfect measure. Every measure has its problem. Please try to know that, what you're missing out, and acknowledge. Make sense? That's why you need to do robustness tests as well. Okay. General mean appears to be kind of the perfect measure. Same mean, which is used to construct Gini coefficient, has only one problem, which is subgroup consistency. It doesn't satisfy. What would be the problem? I just discussed subgroup consistency, right? So if it does not satisfy subgroup consistency, what empirical problem you could have? You have North India and South India.
Heterogeneity cannot be.
Not to heterogeneity, suppose you have North India and South India. Income, average, suppose income distribution in the North India did not change. In South India, distribution improved. But Sembin can show overall distribution actually worsened. Policy-wise, theoretically, it may be intuitive or it may be of interest to some people, but think of it empirically. You are an economic advisor. You have worked hard to make improvement in the South. And then suddenly you find your statistician says, no, I'm using this measure, and actually overall it has gone down. You are saying, oh boy, I spent so much resources. How can it be? So, ought to be very careful when you are using this measure. I'm not saying it's a bad measure. It has several other features, but at least on this particular property, it's blind. Again, using it, no problem, but knowing where it can falter can help you. If you are interested in subgroup decomposition, you are looking at subgroup decomposition by gender, by states, and so on, you ought to be careful. Okay, it can lead to inconsistent results.
What's more?
Yeah.
Regarding subgroup consistency, by default, we assume that there is a mutual exclusive group, or given it relaxation of the assumption that can we go for the non-mutually exclusive groups?
Yeah.
That can be.
First of all, what do you mean by non-mutually exclusive group? You have to understand the situation. Give me an example of a situation where you have non-mutually exclusive group so that I can tell you, I can give you the answer.
I have not thought about when you talk about North India, South India. There, though, it is mutually exclusive. So some states
mutually exclusive and collectively exhaustive. That means one person cannot, when you are doing the census, one person cannot appear in two states, right? Otherwise, there will be double counting. And at the same time, you are not leaving people out, you are including everybody. That's called collectively exhaustive. So please share me with the situation. You may have something in mind of an empirical situation where you think they're either not mutually exclusive or not collectively exhaustive. Then I can think of the situation. Do you have one? No one. Okay. So what we need to do, we all need to think about things in practice as well. Yeah. Based on which that sort of I did, because the most usual situation would be they're mutually exclusive and collectively exhaustive. Does it make sense? I mean, that's why I'm not willing to at this moment think about the relaxation of this particular assumption. Is that okay with you? Okay. Any other questions?
We are only focusing on the general means alpha is less than 1. Only the case was mentioned is
Inequality averse. If you don't like inequality, you will choose alpha less than 1. If somebody here, it says, I'm taking a name, and I know it's on record, our US president, probably he's an inequality lover. Okay, more inequality is good for this person. More global inequality. One country should be richer, others should be poorer. He would probably choose alpha greater than 1. I will come to that. I mean, it is not finished yet. I'm not moving on. I will come back to it.
yes.
But is that something you are going to ask about the value of choosing alpha?
Yeah, why it's only in the special case of alpha is less than 1. Okay, if I'm not an inequality lover also, I have several options. I have to think about that aspect also.
I will come to that. I will try to come to that. But you will see in this this is why it is called normative economics. Because in positive economics, you just say, this is what you should use, kind of a dictator, right? Here you have choice. People typically use geometric mean, harmonic mean, that's good enough. Rawlsian world, Rawls would choose alpha equal to minus infinity. Because he's saying, I only care if the income of the poorest person has improved or not. So alpha has to be minus infinity. Yeah. But generally, people conduct a robustness check. For example, you can draw the graph, say between alpha equal to -2 to alpha equal to close to 1. And you see for all alpha values, you have one above the other and so on. It's called robustness test. We'll talk about it a little bit. Yeah. Good question. Any other questions? Okay. So this part probably will be of interest to you, just based on the question just I had. So let's have a look at whether general mean and Sen mean can be seen as a welfare measure. Yeah. So they can be because they satisfy transfer, and transfer is related to diminishing marginal return or marginal utility. We are all economists, right? We all understand the idea of utility. Yeah. So let's talk about the concept of equally distributed equivalent. You all have taken basic microeconomics at some point in your life. Have you read lotteries, expected utility theory, and so on? Have you heard the term certainty equivalent? Can anyone tell me what this is? Sorry, just going back to the basics, but it will be helpful. You remember something called certainty equivalent? So if I give you a choice of unequal, of lottery where you have 99% of winning 100 rupees, 1%, of winning 1 million, and then I give you a certainty number, okay, would you choose that lottery? Or rather, you would choose 10,000 rupees for certainty. Some of you may accept 10,000, some of you may not, right? Some of you may say, oh, I would rather accept 20,000. So 20,000 for you is the certainty equivalent of that lottery. So you are saying, rather than playing that lottery which is unequal, I would rather choose a certain number. That's called certainty equivalent. We use the concept, Atkinson actually did use the concept called equally distributed equivalent. So you have a distribution which is unequal. Which equal distribution of which income would be equivalent to that for you? Now that can differ from person to person. That's where the choice of alpha comes into play. That's why I cannot choose a particular value of alpha, because I may be more inequality averse. I'm willing to choose alpha equal to -1. You may be less inequality averse. You may say alpha equal to 0 is sufficient for me. That's why we cannot choose one. But they can be seen as equally distributed equivalent. Let's see how. So it is that level of achievement, if received by everybody in the society, perfectly equal society, would yield the same level of welfare as the original unequal distribution. Okay, so suppose we have a distribution of 10 rupees and 100 rupees. Suppose 2%. It's an unequal distribution, right? 10, I have 100. Now I can say, okay, I can have another distribution where both persons have equal incomes. Okay, so let's now see what do you think? A little experience. So I give you 10 and 100. It's one distribution, and then I have another distribution where income should be equal. What income do you think that should be? There's no right answer. 10 and 100 is the unequal distribution. How much? What kind of equal distribution you would prefer?
So it can be 55-55, it can be 60-50, it can be 40-70.
But what as value you will assign, that will determine how inequality adverse you are. I'm not calling you, I'm not asking you to go from 10-100 to a distribution. I'm giving you 10-100 and say 40-40. 10-100, 35-35. Where you will find which particular equal distribution you will find to be similar to 10-100. That's where the question is. It is not about taking 10-100 and equally distribute. I'm not talking about that. 10-100, but if I give you 35-35, would you rather choose 35-35 or 10-100? Would you rather choose 40-40 or 10-100? Is the equivalence that will, I bet, will differ from you all. If I ask you to play the same lottery, all your certainty equivalent will be different. Yeah, that determines inequality averseness. Okay. So what Atkinson did, some of you may have seen when you did expected utility theory, you may have seen this kind of utility function. It's inequality averse utility function. So it's alpha less than 1. You have this particular function. It's similar to a single dimensional approximation, but it's a risk averse utility function. And then you have ln x for alpha equal to 0. Now, if Atkinson used this particular utility function, and then it turns out the equally distributed equivalent is nothing but the general mean itself. This is what he proved in a 1970 paper. So you start with a distribution, and suppose you have this risk averse or inequality averse utility function, then it turns out your equality distribution equivalent is going to be the general mean itself. It's a beautiful result. That's why general mean can be used a welfare function. Sane, on the other hand, is not an utilitarian, but even if you go beyond this utilitarian framework, equally distributed equivalent in same world is the same mean itself. Okay, Atkinson's used an utilitarian framework to come out with that, but for sane, this is same mean itself is the equally distributed equivalent. Okay, so that's why these two can be seen as welfare measures as well. Okay. Now I'm moving on. I could talk to you. I mean, in general, when I teach, I generally teach these things over 2 days. We have to finish it. Okay, so I'm moving on. It's not, that's the only reason I'm rushing, but I'm happy to talk to you whenever over lunch or anything, whenever we are here or tea or anything. Now, dominance and unanimity is important. You ask, what value of alpha? Why I choose alpha? Why I choose alpha equal to 0? Why not alpha equal to -1, right? So dominance and unanimity, let's talk about what it does. Suppose we have this quantile function Qx. Yeah, the entire distribution. I'm not talking about a particular measure. Suppose we have this blue distribution, we have this red distribution. Yeah, we have three distribution. Question: under what condition can we say that all income standards doesn't matter, quantile income doesn't matter, partial income, same mean, general mean, it doesn't matter which alpha you choose? Can we say something under what condition, no matter what income standard we choose, they all will lead to improvement? That would be beautiful, isn't it? You don't have to choose. If you present geometric mean, somebody will not ask you, what about harmonic mean? What about Rorschach mean? What about same mean? You could say it doesn't matter, man. You choose whatever you want. There's an improvement. What is that situation? Sorry? Qx prime. So when one quantile lies above another quantile function, okay, so you plot. So you know what you should do? You have your distribution. income distribution, you can have an environmental indicator distribution. You just plot the quantile functions. You don't have to compute anything. If one quantile function is above another quantile function, it does not matter. You choose general mean 0, general mean -1, same mean, everything will show you an improvement. This is called dominance and unanimity. That means all measures would agree that one distribution is better. Okay, so here you have it is when one quantile function is above another quantile function for every percentile. This is called first order stochastic dominance. Have any of you heard about the term first order stochastic dominance? People in corporate finance talk about it quite a lot. But this is what first order stochastic dominance is. That one quantile function is above another quantile function. Okay, how am I doing with time, Pratap?
We have another 5 minutes.
We have another 45 minutes. Okay, I will try to be a bit quick, but again, we can talk about it over team. So, what first order stochastic dominance is that one quantile function always has to be above another quantile function. That's the idea. Sounds good? Okay. So, we had situation of blue and red crossing each other. If they cross, then different measures will disagree. Some measures will say income has gone up, channel has gone up. Somebody will say distribution has deteriorated over time. But if you have one above the other, beautiful. Everybody will agree. Okay. In terms of CDF, we can have equal statement, but here the sign just changes because of the axis. But I will come back to it when we're talking about poverty. Yeah, not to worry about it if you don't understand at this moment. I will come back. Here's an example. This is a paper from Branko Milanovic, who is at the World Bank. So what he did, he presented, these are called concrete ventiles. Ventiles means you present them in 20 equal groups. They're called ventiles. Yeah, so you have ventiles here. And then you have the income percentiles. Here's the percentile of world income distribution. And here you go. This is India distribution, but they're old data. It's a paper published 10 years ago. Then here you have Brazil, you have China, you have Russia in the United States. So you can see United States probably will dominate India. You take any income standards, United States will perform better than India. So you don't have to say, oh, what about I use same mean? What is inequality sensitive measures we use? It doesn't matter. Whatever you use, one is just above the other, will always dominate the other. Okay? If you use China and Brazil though, and you use a value of alpha very much lower, say alpha equal to -2, -3, China will be doing better than Brazil. Because here they intersect. You cannot say dominance. You cannot find any dominance here. You see how these things, how the dominance idea can be applied here. So you do not have to choose a particular measurement. But when they intersect, like you have here, like Brazil and Russia has intersected, we cannot make dominance conditions. But if you say, okay, what about between these, this part of the distribution? Still, you should be able to say, if you look at say 5 and 15, yeah. So this is 5 times 5, 25th, and this is 75th. If you take 25th, 75th, you have clear dominance. You can rank the countries, and it doesn't matter in that for that region which measure you use. Yeah.
What is that red color dotted lines?
I think this is kind of 60% of 60th percentile of the global income. Like that. Okay. I will talk very briefly about this concept, but I'm not going to force you, but this is just for your information. We were just talking about this concept. Whenever parts cross, this distribution cross, it's not just all hopes are lost. We can move to something called second order stochastic dominance. Yeah. And I'll be using this concept because from this particular concept, I will show you what Lorentz curve is. You have heard about Lorentz curve, right? Okay. They're linked. Okay. This is something called, for second order dominance, we generate something called generalized Lorentz curve. So when first order dominance doesn't hold, You cannot make that strong statement. You go to second order dominance. Yeah, let me show you very quickly how it works. Let me show you graphically. It's easier. So suppose you have this distribution 10, 15, 20, 25, 30. It's an unequal distribution, right? It's not equal distribution. So if I try to plot the percentile or the quantile first, this is how it looks like. Look. So this is how it looks like. The quantile function. It's a space function. As I so told you, it's not necessary that it has to have a particular shape. But I just plot it for these 5 values. This is how it looks like. It's like a state. Yeah. Now, how do we draw a generalized Lorentz curve? It will be the area under this quantile function for each of these percentile. What is this? So you take the area, so 10 times 0.2, which is 2 here. Second one, you add a plus b, so that means you have 0.2 plus 3, which gives you 5, and so on. So if you keep on doing that, if you keep on adding this area, this is what you get called a GL curve. Now, just you ask why quantile function is not linear. Here, you can have the linear part. You have this linear part. This is called line of equality. If your distribution is perfectly equal, you get this straight line in generalized Lorentz curve. And for this one, the height is the mean itself. Remember, the entire area under a quantile function is the mean, is the average. So the height of the generalized Lorentz curve is the average itself. But that gives you some idea about how much inequality you have in this distribution. Because if the distribution is perfectly equal, we'll end up getting this straight line. Yeah, I'll be using this concept. I will coming back to it. So for second order dominance, then distribution is second order dominance distribution Y if the GL curve lies above another GL curve. So you plot these two GL curves, one is above the other. So if distributions cross, you can look at the generalized Lorentz dominance. You have a question? Sorry, you were raising your hand, so I thought. Okay. Okay. In general, the policy relevance is that if you are interested in just ordinal ranking, if you just want to say India's distribution between 2010 and 2020, has there been an improvement? Ideal would be you plot these two quantile function and see if one is above the other. If one is above the other, does not matter what indicator you use average, general geometric mean, harmonic mean, anything you use, you will observe an improvement. If they intersect, you can still plot a generalized Lorentz curve. We'll show some of the comments are there, I guess, Pratap, I think I share with you. If you plot, if you see dominance, fine. You can still say one is better than the other. If a generalized Lorentz intersect, sorry, we just have to choose a particular measure to see improvement has taken place or not. Yeah. Okay, I will just keep it. I will just very quickly cover the idea of inequality. What we looked so far is the idea of distribution, the size of the distribution. Let's very quickly in half an hour or so. Yeah, so very quickly go through some of the idea, the concept of inequality, and how you can see these different inequality measures we see, they are actually very simple. Yeah, let me show you and how they're linked to the concept of achievement standards, what we have covered. So you can have a situation, you have a quantile function which is crossed. Which quantile function you think is more unequal? Which quantile function? They are both crossed through this 50%, that means they have same median. Which distribution you think is more unequal? Which one is more equal? Red one is more unequal? Yeah? So the idea is that you have, so red and blue have same median, but they are quite different from each other. Red has more spread than blue. You are talking about variation, right? That means more unequal. So if you think in terms of top 20 and bottom 20 ratio, so you have 20, and then you have these 80th percentile that gives you top 20. And if you just look at their percentiles, look at the difference between percentile, right? It's much, sorry. It's much wider for rate and much smaller for proof. So that means that gives you an idea of inequality. This is one way of looking at it. Right? Now, measuring inequality. We will try to see two different ways, just for your understanding. Yeah? One way is through desirable properties, as we already have done. And the second is through its link to achievement standard. Let me just show you how. So, we are going to be denoting inequality measures as I, and we'll be using different suffixes to denote particular one. Exactly. Okay. So, desirable properties. Symmetry, you already know what symmetry is, right? If we just change parameter everybody's income, inequality should not change. Why it should? Because it's the same income distribution. We have just changed different people's income. Population invariance, same thing. You just replicate, you just create a bigger society. But they're equally unequal. Why should inequality change? Because of that. Then transfer, it is the heart of inequality. Regressive transfer, inequality increases. Progressive transfer, inequality goes down. Simple as that, right? Normalization is a convenient property. If everybody has same income, there is no inequality, right? Why not we just assign a value of 0? This is a natural thing of emptiness. 0 means empty. No inequality is equal to 0. If you have an inequality, you are saying there is no inequality, but we get a value of minus 30. Doesn't make any sense. Okay. Now, I'll be talking about two properties now, they're controversial. And I would do an experiment, very small experiment, which side you are on. Yeah. So the idea of scale invariance says that if you increase everybody's income by the same factor, if you double everybody's income, inequality should not change. That is a good application. What? We have our income in rupees. We use an exchange rate to convert everybody's income in dollar. Should that change inequality? That is a veil that policymakers use to justify certain things. Let me show you how. Here is another property, which is called translation invariance, which says if I add the same amount to everybody's income, inequality doesn't change. And there cannot be any measure that satisfies these two properties. Okay, there's an experiment. Suppose this experiment is about you and your friend. You have income of 10,000 rupees per month. And your friend, rich friend, has an income of 1 lakh rupees per month. So you have 10,000 rupees per month, your friend has 1 lakh rupees per month. Yeah. Your income goes up by 1,000 rupees. Your friend's income goes up by 10,000 rupees. Are you happy about this improvement?
Same.
I ask you, are you happy about this improvement or not? Forget about same or non-same. Who cares? First, are you happy about it? Your income has increased 10,000 and then 1,000 by how many percentage? 10%. Your friend's income has gone up 10,000 rupees out of 1 lakh. How many percent? What percentage? 10%. Are you, and I come and tell you, you know what? I'm an employer for both of you. I say,
No.
why are you unhappy? I mean, both of your income has gone up by 10%. Do you think you have sufficient reason to be happy?
No.
Do you think the situation is equally unequal?
Unequal.
Who said same? No. We have justifications. Don't worry that I'm singling you out. Are you saying that you should feel same about it? You should not feel bad. You should feel bad, right? Anyone who thinks that no, it's indifferent, I'm perfectly happy with the situation?
Generally, we are having a tendency to look into the absolute value, not the relative one.
No, but the question is, as you personally feel happy or not about it?
Not
Done. But a policymaker comes and tells you that situation is equally unequal. Even worse, here is another example. Your income increases by 10,000, but your friend's income increases by 9,000 rupees. Your income increases by 1,000 rupees, friend's income increases by 9,000 rupees. Happy about it? No. A policymaker comes and tells you, no, actually the inequality has gone down. You should be happy. If you use Gini coefficient, if your policymaker is using Gini coefficient, you will say inequality has gone down. You are not happy. So it is a debatable, it is a really controversial property, whether we should look at increasing everybody's income in the same proportion, leave situation unchanged, or increasing everybody's income by same amount, leave situation unchanged. So if you get the same example, 10,000, 1 lakh, your income increases by 100 rupees, your friend's income increases by 100 rupees, manageable, fine. You both are getting 100 rupees more, probably acceptable. Increasing by the same factor may not be. So we ought to be careful. If you blindly come and say, oh, I'm studying inequality and I have used Gini coefficient has gone down. Trust me, if I use an absolute measure, income inequality in the last 50 years has gone out of the roof. Relative measures fine. So be careful. If somebody is just showing you I have used Gini and inequality has gone down, don't take that in blind faith. Please ask, are you a right wing or are you a left wing? This is what it is. Okay? So, Sarge Cohn, great economist from the time of Amartya Sen, and many people ask, French people ask, why he didn't get the Nobel Prize. Okay? That good. He had a nice paper in 1976 where he calls the first approach as a rightist approach, a right-wing approach. The left one is a left-wing approach. And I bet most of you would lie somewhere in the middle. You may not go to one extreme. If somebody comes and tells you Gini coefficient or any other relative measures, ask them, are you right wing? Are you rightist? If you are probably somewhere in the middle, centrist, but you, by using Gini coefficient or 9:10 ratio, whatever you use, you are showing your right wingness implicitly, although you are not. So just be careful about it. You see how measurements can distort things? It's very important to understand what we are measuring. Okay. And then subgroup consistency idea is the same. If you have two subgroups, you have no change in inequality in one subgroup, but increasing inequality in another subgroup, overall inequality should go down, go up. Again, Gini coefficient violates it. It is possible your no inequality improves change in one subgroup, inequality goes down in another one, overall inequality for Gini coefficient can go up. Ought to be careful. Okay. So relative inequality and achievement standards, how are they linked? So suppose we have a lower income standard A and or achievement standard A and a higher achievement standard B. It could be mean, geometric mean. It could be mean, semi mean. One is higher value, one is lower value, right? The inequality measure just can be a function of the ratio of these two. So either you can write it as B minus A over B or A minus B over A, however you do, but all of them take the same form. Yeah? Okay. Common relative inequality measures. Number one is percentile quantile ratios, and you will see OECD reports is, World Bank report is, country statistics, you will have 90-10 ratio, 80-20 ratio. Still, they're relative. That means they're right wing. I'm just using this word, rightist approach. Yeah? Partial mean ratios, Kuznets ratio, Palmer ratio, share of top 10% versus share of income share of bottom 10%, they all fall in that category. And then there are measures based on the entire distribution. There are Atkinson's class of measure based on general mean. There are Gini coefficient, and there is something called generalized entropy measure. I will show the functional form, but don't get scared. It generally, if you use different kind of work, you will get. So all the inequality measures are summarized here. Yeah. Very briefly, if you are looking quantile ratio, you just look at the ratio of upper quantile and lower quantile. So you're just saying how much income, how much is the 90th percentile, how many times higher the 90th percentile is to the poorer percentile, and so on. Similarly, for Atkinson's measures, alpha less than 1, what is the inequality measure? Oh, the average, the mean, minus, say, geometric mean, harmonic mean, however you choose, divide by the average. That's your Atkinson's measure. What is Gini coefficient? You saw, sometimes you see very complicated form of Gini coefficient. Not to worry. It's the average minus the cell mean divided by the average. This is Gini coefficient. Okay. Similarly, generalized entropy, or only one measure I will just show you very briefly. It doesn't satisfy these two standard representation, but otherwise they just can be represented as a function of the ratio of two achievement standards. Okay, that's what they are. Okay, this is how the generalized entropy looks like. It came from physics actually, and people use because they have some good properties. Again, I'm not going too far in details. Just I have it. If you need it, because I'll be sharing the PowerPoints with you. If you just need it, it is just there. Yeah. Properties. What do they satisfy? These inequality measures. These measures depend on the part of the distribution. Do they satisfy some of these basic properties? But if you go to transfer principle, subgroup decomposability, and all these things, they do not satisfy. Atkinson's measure is good, but inequality decomposition is not satisfied. The idea is that the total, if you are trying to understand, say in Indian states, you have the overall inequality, but then you want to understand, is this inequality because of the total inequality across the people within states, or is it because of inequality across states? You can break the inequality measure down to understand total within group inequality and between group inequality, within state inequality and between state inequality. If you're able to break that down, that means your measure satisfies additive decomposability. Atkinson measure does not do that. Yeah. Generalized entropy looks like, again, the perfect child. They satisfy all of them. Gini coefficient also does not satisfy additive decomposability, nor it is subgroup consistent. For your research at any time, please be careful what they can do, what they cannot do. Very important as a researcher. That makes you a good researcher. Okay? Inequality decomposition, just wanted to show you how it works. So if you have a decomposable inequality measure, the idea is that this is the total within group inequality. Suppose I said, take the Indian states. Suppose you divide again India into two groups, northern states, southern states. Yeah? Mutually exclusive, collectively exhaustive. Then this is, say, the inequality within north, or better, let's do gender. Female-headed households, male-headed households, and so on. So inequality within female-headed households, inequality within male-headed households. Then you use some sort of weights. They can differ from measure to measure. And then the second component is between group, so gender inequality. So you take the average of the females, average of the males, inequality between them. So if you can break down this overall inequality measure into these components, that is called additive decomposability, that allows you. So if you are trying to understand inequality within state, inequality across states, you rather want this particular property to be satisfied. Yeah, you cannot use Atkinson because Atkinson cannot be broken like this. You cannot use Gini because I will show you what problem you have. So it can answer the questions: how much was the change in, say, global inequality due to change in within countries, change in between countries? If you are doing within a country, has the reduction in inequality within a country accompanied by a reduction across regions, across castes, across religions, across other ethnic groups, and so on. Yeah. That takes us to the concept of vertical versus horizontal inequality. I'm not going there. Vertical inequality is basically inequality across the people. Horizontal inequality is much more inequality across groups, inequality across caste, religion, gender, and so on. Okay. Gini coefficient decomposition. If you decompose Gini, this is what you get. Your total Gini, you can have the Gini of, say, between among females, among males, inequality. This is a gender inequality, but you have a residual component that most often comes that prevent you from having that beautiful decomposition of within between. And in which way this residual will go, it is not clear. So that's why if you are using this between group, within group decompose, sometimes we try to understand disparity in poverty. We talk about it. You have poverty reduction, you have energy poverty reduction, but you want to understand it. Has all states done the same thing? Or how dispersed it is across states? Yeah? Has it converged? If you want to do that kind of analysis, you cannot do it. Yeah? Generalized entropy, in general, they are decomposable with these very difficult, weights. But there is one particular tail, type of Gini, which has a beautiful decomposition, where these weights are just population shares. Okay, so if you want to have these beautiful decompositions where for total within, you just have population weighted share of within group inequality, you can use this particular tail to decomposition. It's in my slide where I have discussed, presented all the measures. How much time do I have, Pratap?
15 minutes.
15 minutes. Okay. So let's talk about what we mean by dominance and unanimity in inequality work. We did it for income standard, right? We devise situations where we can say, if these situations prevail, one quantile function above the other, no matter what income standards you or achievement standard you use, you have improvement. What about the inequality work? Can we have some situation? So it may be possible that relative inequality measures disagree, but if there is any condition under which relative inequality measures should agree, that is called relative Lorentz ordering. You have heard about the Lorentz curve, right? Okay, yeah. This is what Lorentz ordering. If one relative Lorentz curve is inside another, that means more equality. Okay. So if inequality measures, all Lorentz consistent inequality measures should agree with the relative Lorentz ordering. So if you have Lorentz ordering, then if one Lorentz curve is above or inside another Lorentz curve, then all relative inequality measures will come and agree with you. You do not have to check. So the first thing as a researcher, plot your Lorentz curves. See if one is inside the other. If it is one is inside the other, you don't have to choose an inequality measure. Any inequality measure would do. If they intersect, it's a different ballgame. You have to use particular measures. Okay. So what are Lorentz consistent measures? A relative measure, inequality measure that satisfies symmetry, population invariance, transfer, but this controversial scale invariance. So many of you, have you used Lorentz curve? Any of you? In your research or any time? No? Yes, be very careful about right versus left wing gang. Okay? So it satisfies scale invariance. I will show you the absolute version of Lorentz curve as well, what you can do. So the examples would be Gini coefficient, Atkinson's measure, G measures, all the measures that I've presented. Okay. So from generalized Lorentz curve, this is what generalized Lorentz curve was. What you can do, for Lorentz curve, a point on the relative Lorentz curve of a distribution P is just the generalized Lorentz that we had drawn divided by the average. Yeah, let me show you in terms of the picture. And the interpretation of the Lorentz curve is that a point on the Lorentz curve is the share of the total income held by the bottom P% of the population. So if you look at the bottom 20% of the population, if they're holding only 2% of the income, that's highly unequal, right? This is what Lorentz curve gives you. So this was our generalized Lorentz curve. We already drawn it, right? Remember, we took the area under the quantile function and drew it. If we have that, now what we are doing, we are drawing the Lorentz curve from here. How we do that? Well, this one is 2 divided by 20. So only 10% of the average income here. You see? Similarly, for the bottom 40%, you have 5 divided by 20. So here, bottom 20% of the population has 10% of all income. Bottom 40% has only 25% of all income. Right? So if you keep on plotting them, that's your Lorentz curve. Line of perfect equality is this one. Why? If everybody has same income, that means bottom 20% has 20% of income. Bottom 40% has 40% of income. Bottom 60% has 60% of income. That's the ideal situation, a situation of perfect equality. So, how much Lorentz curve is formed tells you how much inequality is there. Okay? So, if you have another Lorentz curve which is inside, will it reflect more inequality or less inequality? Less inequality. Okay. Let's talk a bit about absolute Lorentz curve. So some of you have seen relative Lorentz curve. Yeah, what I had lectured on. How many of you have seen absolute Lorentz curve? Any of you? Interesting. So this is new. Okay. So what do we do? So it comes from the idea of translation invariance. Okay, so if we have translation invariance instead of relative invariance, then a distribution X is obtained from X prime obtained from X, so that you have added the same amount to everybody's income. Now, the measures that you can use for absolute inequality is standard deviation. Standard deviation is the measure of absolute inequality. Absolute Gini. How do you measure it? You just multiply the Gini coefficient by the average. It gives you absolute Gini. Then you can use absolute mean deviation. You have heard about some of those. They are all absolute measures of inequality. Okay? Now, how do we do Lorentz dominance? When would all these measures agree? So, it is when absolute Lorentz curve lies completely above another absolute Lorentz curve. But how do we draw them? Okay, let me show you the steps. So, first step is to construct a mean censored distribution. So, you have the actual distribution. You subtract the mean value from each of these income. You have a mean censored distribution, yeah, which is x minus x bar. You draw the quantile function of this mean censored distribution, and you just simply take the area underneath for each percentile. That gives you absolute Lorentz curve. In terms of picture, how it works. So suppose you have the same distribution now, 10, 15, 20, 25, 30. We give the, what is the average? So I did the calculation right? I was just thinking whether I have done the calculation wrong. I make mistakes. Sorry. So if you subtract 20 from each of this income, look, you get 10 minus 20 minus 10. 15 minus 20 minus 5 and so on. Right? Let's now try to draw the quantile function. If I draw the quantile function, this is how the quantile function is going to look like. Look, it has just shifted below by the mean. Now let's calculate the areas underneath this quantile function. So you start with here. Okay, this is the A now over here. So once you do, this area is going to be this one, minus 2, because you have minus 10 times 0.2, that is minus 2. Then you have A plus B. So you add another minus 1, minus 5 times 0.2. You add another minus 1. This is what you get. For the third one, you do not add anything. It's 0. No area, right? That's what you get. Then similarly, now you are adding positive numbers. It goes up like this. And then there you go. This is how an absolute Lorentz curve looks like. So if an absolute Lorentz curve is higher, it will reflect less inequality or more equality. This is perfect equality line. If you move up, that means it's more equal. Make sense? This is perfectly equal because you will have a distribution where you will have this area to be 0, 0, 0, 0, 0, and so on. Sounds good? So that kind of the conceptual discussions of income standards and inequality. We wanted to start with it because yes, it is about poverty, it is about energy poverty, but unless you know the preliminary discussions, and you will see some of them, although you are just doing poverty, some of them will turn up. We cannot just simply do poverty without understanding. So that's why I wanted to spend 2 hours at the start with you, go through some of these preliminaries. Now we'll be building the rest of the module for the next few days based on what we studied. So the first lecture was about achievement standard and inequality. We'll be building on them for the post lunch. Now you guys are hungry, I guess, after listening to me for 2 hours. Have your lunch, we'll come back, we'll talk about monetary poverty, single dimensional poverty. It's not just monetary poverty, we'll be talking about in terms of monetary poverty, but if you have an education indicator, if you want to study deprivation in education or deprivation in one indicator, you can use those tools. We will be learning about those, and then you will have an exercise in the evening. I'll provide you the exercise, the answer key. Please try to solve without looking at the answer key first. Then you can check with the answer key. Yeah, that will help you to understand it better. And then we will, I think, Pratap, you will have a session on theta. Well, Pratap will show different things, but then we will show a little bit how to construct, these cumulative distribution functions, quantile functions, and all the things in theta. Okay. Any questions before we break today? Were there any new material that you did not know you learned, or you knew most of these things? You knew most of these things. So how many of you there were some new materials? Okay, fair enough. Oh, you too. There you go. Okay, good. Any questions? Yeah.
This is tail 1 and tail 2. The tail index, there is when tail 2 is alpha equal to 0 and tail 1 was alpha equal to 1. And both tail 1 and 2 index are for regional disparity, or like what is the difference between tail index, tail 1 and 2?
Let me go there.
I think they are for the below that 10% or something.
Yeah.
No.
This is the one you're talking about?
No, sir. Where all the index, inequality index are there.
So this is tail 1. This is tail 1, and this is tail 2.
Yeah, like basically, tail index is for regional disparity.
No. It is an inequality measure.
Yes, sir.
Just like others, but it has the property that once you go here,
This one.
tail, the generalized entropy, tail 1, tail 2, they all satisfy these properties. Yeah. So if you are doing decomposition analysis, any generalized entropy will do. Yeah. Now generalized entropy 2. Generalized entropy, if it is 2, this is called coefficient of variation. Yeah, variance divided by mean. Yeah. Now, what is the addition of tail 2 is when you are doing this decomposition, your decomposition is saying that weighted sum of within genes, right? For generalized entropy in general, for alpha not equal to 0 or 1, these are your weights. This is population share times the ratio of mean to the power alpha, right? Now here's a question for you. Suppose again, we have gender, male and female. Suppose the inequality between males did not change, but their average went up. The inequality between so for females, the average went up, which is different from males, but the inequality also changed. Would you want those change in means to affect this within group inequality? Your average change, but why should it affect within group? Between group, I understand. Within group should not, right? But here, look, this within group component has mean as a function. But you do not want that.
Yes.
L2 is beautiful because the weights do not have any mean component. So if you want that, if you say my within group inequality should not be affected by change in the average, why should it? You should use THEL2. THEL2 is the only measure. There is no other inclusion. THEL2 is the only measure, relative inequality measure. You are still in the rightist world. Only inequality measure that satisfies this particular type of decomposition. Does it make sense? Sorry that I had to rush at that point of time. Again, as I said, I would rather teach it over 2 or 3 lectures, but it's only 1 hour. Yeah. So I tried to summarize very brief. You have the PowerPoint. If you have questions, feel free to get back to me. We have time to interact. Yeah, over lunch and over tea times and so on. Sounds good. If you have any questions.